Hello everyone, my name is Jazmin Pardo Benitez, and today I will be presenting the boron applications in cancer treatment. To begin and to clarify, I today will be focusing on the boron neutron capture therapy. There are two forms of boron cancer treatment, and the other one is called boron nitro nanotube therapy, but I will be focusing on the boron neutron capture therapy. So to initiate, its therapeutic purposes are non-invasive. It's a form of neurotherapy, and it's considered the ideal type of treatment because it's able to target the cancer physically and biologically, and its ability of being less invasive is obviously more favorable within the patients, and it's very effective. It's usually used to treat the recurrent cancers in the head, brain, and neck, but it can also treat high-grade glycomas. It uses a boron 10 drug, which boron 10 is an isotope of boron in its neutral state, and it's able to localize a tumor and is radioactive in its chemistry. So I don't think we need to stress the importance of, various forms of cancer treatment, but cancer is the second leading cause of death in the United States for, many years. Cancer is a threat to the human population in general and a global scale. So, cancer can range from being mildly impairing, to a person, and it can result in, a fatality. But therefore, more studies and research, various forms of treatment, they're important because it can lower the amount of fatalities from cancer, which is a threat, like I said, to the human population. So here you can, search it up yourselves anywhere. You can see that any graphs show that cancer is the second leading cause of death in the United States. Here it's in 2014. In the first image, it's 2016 and 2017. In the CDC website, it says that in the year 2018, that there is around 566,274 people that died of any type of cancer that year as a leading cause of death, second leading cause of death as well. Now, the history of the boron created as a form of cancer treatment began in 1932, where Sir James Chadwick discovered that boron 10 could capture neurons, hence the name boron neutron capture therapy. And that image right there is Sir James Chadwick. And then a couple of years later, another scientist, Locher, discovered the element's potential for cancer treatment because of its ability to capture the neurons, and suggested it to many medical professionals and organizations. But even though this, began in the 1930s, I would say for, those whole 60 years, this was a brand new type of treatment and method. So it did face many weaknesses that I will address later, and its effectiveness began in the 90s, and it's what we know today as the boron neutron capture therapy. So here I kind of summarize the process, the two-step process for the treatment. And it's the patient becomes injected with the boron 10 drug, and the drug captures the slow moving neurons. Then once the patient is radiated with the epithermal neutrons, they penetrate the body tissue, and as they penetrate the body tissue, those neutrons begin to lose energy, and then the boron 10 becomes a boron 11, and then the neutrons become absorbed, right? And then here I put just a little mini image of what fission would look like, just so you guys can have an idea. So how exactly does the boron therapy kill the cancer cells, which is, the goal of cancer treatment? So the moment where the epithermal neutrons start becoming absorbed by the boron drug, the action results in a fission that yields to high energy alpha particles and lithium ions. So the alpha particles and the lithium ions are the ones that technically destroy the cancer cells. So here I have a model that, can help show more easily what it is. So here's the neutron and the boron 10, and then as it becomes radiated through the epithermal neutrons, it loses energy, becoming the boron 11, and then that fission yields in alpha particles and the 7 lithium, and that reaction is what targets the malignant tumor, killing the cancer cells. Here's another one of a patient, it would be a brain tumor, and you have the neutron beam of the boron 10, and then you see the boron 10 yield to the lithium and the alpha particles, targeting the tumor, killing the cancer cells, resulting in the lysis of the cancer cells, actually. So, although the boron neutron capture therapy is highly effective today, it faced some weaknesses, like I was talking about earlier. For about 60 years, its research was, it faced some weaknesses. And as in the 1930s, when they suggested it to many medical professionals, it was still facing a lot of criticism, and it faced a lot of disappointment, in science and its research. So one of the main weaknesses was that there was they didn't know the ideal boron pairings that they could use, like the boron 10. They struggled with that in general, but they knew that boron's, state in general would be able to, have that potential. It lacked of controlled prospective trials, and there had a need for nuclear research reactors for testing its irradiation. So, it did face a lot of weaknesses, and for the 60s, it wasn't as used and effective then, but now it has been deemed by many professionals and scientists and researchers as, safe, and it is safe today, and it is still highly used today, especially for the cancers that I mentioned about earlier, like the ones in the brain, the head, and the neck. So my final conclusion is, yes, around the 1990s, it became very effective and deemed as safe, and it is what we practice today. It has revolutionized the world of medicine, especially for cancer treatment. But my final, thoughts and conclusion would be, yes, even though it's safe, that, we still, in the world of medicine and science, we still need to move forward and find a cure for cancer. So hopefully from this treatment, we can find a cure, and, just from their research and their findings, just to keep moving forward and see where that takes us. Thank you so much for your time, and I hope you enjoyed. Thank you.